your Algebra 1 exam, your geometry, and your Algebra 2. So just to be clear, nothing over here is going to be useful. Nothing over here is going to be useful. This is the Algebra 2 section. Okay? Pythagorean theorem, I don't know why they give us that, but I don't know. Quadratic formula. So in case you can't memorize it, it is given to you on the exam. You just have to go to the formula sheet and look. The arithmetic sequence. This is when they say explicit. Let's write explicit next to this. Okay? This is the explicit formula. This is the explicit formula for geometric. Those are given to you. Just to be clear, recursive is not given. Okay, recursive is not given. You have to memorize the recursive stuff, which is simple. The geometric series is given. Okay, this is going to be a big one over the next few days. A series we did when we did arithmetic is when you find a total. Okay, and then these two go with trigonometry. Honestly, this exponential growth and decay, I have never used this formula in my life. So I'm going to recommend that you never worry about that formula. I don't even know how to apply that. All right, so these are the formulas that's given, which is not much for everything you have to memorize. But we are going to use the geometric stuff today, so it is given. I just want to stress that. So back to page 285. All right, a geometric sequence is geometric if the ratio of consecutive terms is consistent. So we are looking for what we call a common ratio. So we're going to take A2 and divide it by A1, A3 and divide it by A2, A4 and divide it by A3. Okay, so we're not looking for an adding. We're looking for basically an A2 divided by A1, a multiple. Consecutive terms are common by a multiple of R. Highlight that for yourself. Arithmetic terms are by a common difference. Okay, so that's how you know if it's geometric or arithmetic. I'm going to put geometric here. Okay, geometric has a multiple, arithmetic has a difference. So it says determine if each is arithmetic or geometric, then find the common difference or ratio. So you got to look for the pattern. How am I going from 5 to 15 to 45 to 135? Am I adding or multiplying? Multiplying by what? 3, right? So I can say the ratio equals 3. Let's say you weren't as quick and couldn't see 3. Could you easily rule out adding? They're definitely not going out by the same amount. So here's what you do if it's not super obvious. You go back to this rule. Take A2 and divide it by A1. So let's off to the side, let's write 15 over 5. What is 15 over 5? 3. Take A3 and divide it by A2. 45 over 15. Also happens to be 3. A4 divided by A3. 135 over 45. Also happens to be 3. You got to make sure you go in that order, though. A2 divided by A1, A3 divided by A2. So I can see I have a common ratio. All right, let's take a look at B. 22 to negative 11 to 11 halves to negative 11 fourths. Am I adding or multiplying? Okay, now if you want to think dividing, you just have to convert it to multiplication because it has to be multiplication. So Rohan, you're thinking divide by what? Okay, divide by negative 2. Now I have to make it a multiplication statement, which means I'm multiplying by what? Negative 1/2. So my common ratio is negative 1/2. Okay, so your answer is never going to be divided by. Convert it to a multiplication sentence. Okay, how about 2, 4, 6, 8? Adding what number? 2. So now it's called a difference because I'm adding, and the difference is 2. So geometric has a ratio, a multiple. Arithmetic has a difference. And again, we've already tackled arithmetic. Okay, here's your formula. Where's my highlighter? Where's my highlighter? Where's this thing? Here is the geometric sequence. Okay, it's going to be given. I'm going to highlight this here, and I'm going to write given. This is on the sheet. You just have to look at it. Okay. You always have to find, just like in arithmetic, a sub 1 and the ratio. Okay, you have to find a sub 1 and the ratio. All right, now we're going to start super simple and we'll work our way up. Find the nth term for the sequence. So we're just writing the sequence. So I'm going to start with the rule. A sub n equals a sub 1 r to the n minus 1. Where did I get that? We just highlighted it. A sub n equals a sub 1 r to the n minus 1. So a sub n equals, do you know a sub 1? Yes. It is 3. Plug it in. Do we know the ratio? 2. All raised to the n minus 1. Can I multiply the 3 and the 2 together? Why no? 2 is raised to an exponent. You literally can't do anything else. Geometric is simple. There's nothing more to do once you have it written out. Okay, you cannot multiply that. Do you think that's going to be a choice on the test? Of course they're going to put 6 to the n minus 1 because half of these ding-dongs are going to fall for it. You can't multiply this. This is attached to this exponent, right? We keep boxing in base and exponent. Those are attached. You can't break it apart. So we're done. All right, let's look at the next one. A sub n equals a sub 1 r to the n minus 1. A sub 1 just represents the what term? First term. What's a sub 1? 1. So I'm going to plug in my 1. Okay, now I need the ratio. They told me it's geometric. There has to be a ratio. How do I get from 1 to 1/2 to 1/4 to 1/8? I want to multiply by 1/2, right? If you didn't know that, right, you take the previous term. So I could take 1/8 and divide it by 1/4. I get 1/2. I could take 1/4, divide it by 1/2. I get 0.5. So my ratio is 0.5 or 1/2 to the n minus 1. Again, can't clean it up any further. This is attached to this. All right, now it's going to get ugly. Do they give us a sub 1 at all? No, so this is going to be as ugly as it can get. All right, so let's start with our formula. A sub n equals a sub 1 ratio to the n minus 1. All right, I don't know a sub 1. I can't figure the ratio out right away, right, because I don't have the next two terms. So I'm going to plug in what I can. I can say a sub 4. So I'm replacing all my n's with the number 4 equals a sub 1 ratio to the 4 minus 1. So I'm plugging in 4 for n. All right, now what is a sub 4? 125 equals a sub 1, and this will be r to the 3rd. Beautiful. Okay, that's as far as I can go. Let's write another equation. Let's use this guy. So I'm going to say a sub 10, right? I'm replacing my n with a 10 equals a sub 1 ratio to the 10 minus 1. What do I know about a sub 10? Perfect. Equals a sub 1 to the 9th, right? 10 minus 1. Okay, so now we have a system of equations. All right. I'm going to take, and again, I usually put my bigger r on top. It doesn't matter. You can divide either way. So I'm going to say 125 over 64 equals a sub 1 r to the 9th. And underneath it, I'm going to put my 125 equals a sub 1 r to the 3rd. And because this is multiplication, the opposite would be to divide. So I'm going to divide these two. Let's tackle the nice side. What is a sub 1 divided by a sub 1? Cancels out. What do I do with exponents when I divide? So I'm just going to get r to the 6th. Okay. Can you plug this in your calculator? Absolutely. Type that in. 125 over 64 divided by 125. You just get? What'd you say? 1 over 64? Okay. How am I going to get r now? What am I going to do to that? 6 root. You got it. Well, 6 root that. Again, can you just throw that in your calculator? 6 root. Math. Alex, you with us? 6 root. 1 over 64. should get us a what? 1/2. So now I've got r. So remember, I have to get r and a sub 1. So now I'm going to go get a sub 1. I can pick any equation with a sub 1 in it, right? I'm just going to pick this one because it's handy. And I'm going to jot it down. 125 equals a sub 1. And what can I put in place of r? 1/2 to the third. All right, so let's figure out what's 1/2 to the third turn into. 1/8. And how are you going to solve for a sub 1? You could divide by 1/8, or you could multiply by 8. What do we get for a sub 1? What'd you get? Exactly. Do we agree with that? All right, so now we got to write the rule. Remember, you had to find r and a sub 1. So our rule now is a sub n equals a sub 1, so 1,000 times 1/2 and minus 1. And that's it. You truly can't go any farther. Okay, so it's super nice if you know a sub 1 and can find the ratio. This is where they're going to make you work. All right, let's look at example 3. If they give you this rule, you should just be able to look at it and know the answer. Find the common ratio. Look at this rule. Who is in the ratio spot? How simple is that? Ratio equals 3. What's a sub 1? 4. A sub 1, ratio. They just asked for the ratio. All right, example 4. Take a minute and find the common ratio. It may not be as obvious, so do what we said in the beginning. Find the common ratio. Maybe it is obvious, maybe it isn't. Find the common ratio. Okay, now common means it should be the same throughout the whole problem, right? What are we getting for that ratio? 3/4. How are we getting it? Well, 3 divided by 4, and then 9/4 divided by 3. They should all give us 3/4. A 2 divided by a 1, a 3 divided by a 2. All right, I'll give you a minute to tackle 5 here. It's another ugly one, right? Find the common ratio, so take your time. Start with the first. Write your rule out. Plug in your a sub 2. Plug in your first piece of information. I'm going to start with the rule. So what are we first plugging into n? The number 2. Right? I know a sub 2, so every n is going to become a 2. So a sub 2 is -8. A sub 1, 2 minus 1 is just r. Perfect. Then do the same thing with the next one. Sub in a sub 7. Replace all your little n's with a 7. How do those two equations compare to yours? It's pretty elementary. We're just replacing the n with a 2 and the n with a 7. Okay, again, so I don't get negative exponents, I usually just put the larger r on top. So I'm going to say -256 over 243 equals a sub 1 r to the 6, and -8 equals a sub 1 r. I'm going to divide those. Again, the whole point of dividing is that those a sub 1s are going to divide out. I'm going to get r to the what power here? Fifth, perfect. Negative, I don't know that one off the top of my head. 32. 32?
Over 243.
32 over 243?
Yeah.
Concur with Merrick here? You like this, 32 over 243? Yes, nice, nice. All right, and then I'm just going to take the what of both sides? Fifth root. Seeing it? And what do we get for r? 2/3? Okay. And now that I know r, again, I just have to go get a sub 1. So I'm going to put it in this one, looks the nicest. -8 equals a sub 1 times 2/3. And solve for a sub 1. What are we getting for a sub 1? -12 sounds great. Oh, what did it ask for? Oh, the ratio. I was just excited and went further, I guess. Yeah, I think it just asked for the ratio. Might as well find it all, just for fun. I'm going to write the whole equation. I was just in the groove here. So a sub 1, ratio to the n minus 1. Okay. But yeah, it literally just asked for that ratio. Are we doing okay? All right, flip the page. What else we got cooking here? All right, so just other ways we've seen this asked on our exam here. What is T sub 8 of the geometric sequence? Now, I want you to underline that they called it geometric. So does that mean that you're looking for the difference or the ratio? Ratio. So take a minute and find the ratio. And again, this one's probably not super obvious. Just use the idea. A2 divided by A1, A3 divided by A2. Find the ratio. Now, because my numbers are going down, I know my answer is going to be a fraction, so hopefully you're getting a fraction. And you're right, the signs are flipping, so it's going to be a negative fraction. What are we getting for that ratio? Oops, I didn't hear you. Negative 1/3. Okay. Do we know a sub 1? I think so. What's the first term in the sequence? Perfect. Now I just have to write the rule. So again, this is given. A sub n equals a sub 1. You know, they might in the recursive, but not usually this way in the explicit. Raised to the n minus 1. Okay, so I'm writing the rule. So a sub 1, ratio to the n minus 1. Now that I have the rule, all they want to know is the 8th term. I'm just going to plug in the number 8. So a sub 8 will get me the 8th term. So 6561, -1/3. Can we do this math in our head? What's 8 minus 1 going to get us? 7. All right, and type it in just the way you see it. Okay, parentheses and all. -3. I'm going to take your word on that. So I'm going to say a sub 8 equals -3. A sub 8 equals -3. All right, those two we've done. We might come back to those. Hold on, let me just make sure we've... All right, take a look at 9. Determine a common ratio. So they're telling you you have to multiply by something. So a lot of times they'll get rid of the numbers and they'll start using variables. What am I multiplying by to go from x to -2x? And does that work? If -2x to 4 is also by -2. So that's pretty simple. The ratio is -2. Write the explicit formula. So that's my a sub n equals a sub 1. What's my a sub 1? X. Our ratio we just said is -2. And it's all raised to the n minus 1. Okay, let's get 11 in here. We'll come back to 10 if we need to. Carly is playing with a bouncy ball. She bounces it from the top of a staircase 15 feet high. Each time it rebounds, its new height is 60% its previous height. What are the heights of the first 6 bounces? All right, so let's take the first bounce. How high is it the first time she bounces it? Or I guess when time begins here, it starts at 15 feet. So we know when we begin, we're at 15 feet. We'll plot that point. Now it's going to rebound 60% of that. So what am I going to do now? Just 0.6. Are we dividing or multiplying? Multiplying. So 0.6 times 15. How high are we on our second bounce? 9. Okay, so at 1, I'm going to be at 9. So let's just use some common sense. If I said 50%, what number would pop in your head from 15? 7.5. Does it make sense that I'm above 7.5? 60% should be bigger than that. Okay. All right, so now I need 60%. What did we say that was, 9? Correct. 0.6 is the ratio. So if I take 9 by 0.6, what am I going to get? 5.4. So we'll just kind of list them out here, and then we'll plot it. At 2, I'm at 5.4. So about there, maybe. How about the next 60%? 3.24. Let's plot that. There's 3.24. Next 60%. 1.9. So 1, 2 is about there. Maybe 1.9 is about there. Next 60%. 1.6. Okay. And we'll go one more. Okay, so I was at 1.94, 1.166.699. All right, how would you describe the shape of this graph we just plotted? Excellent. Okay, let's connect that. This is exponential. Does it look like growth or decay? Decay, right? And it made sense it's going down, right? Because it was 60% each time. This is huge. All geometric functions represent an exponential function, which is why we tackle this in the exponential unit. Okay, all geometric functions are exponential. What was linear always going to describe? Oh, crap. What was arithmetic always going to describe? Linear. I didn't mean to say it that way. So linear is arithmetic. Exponential is your geometric. So if you look at the homework sheet, oh, son of a gun, it's on the homework again. Going to have to use a separate sheet of paper. I apologize. Yeah, right. I can be nice. Let's do this. We'll go 1, 5, 7. And then in this section, we're going to go 11, 17, 19, 23, 25, 27. Okay, but it's got to be on a separate sheet of paper. And please, please stick your name on it. Walk by the wall of no names, see if any of that belongs to you. If it does, just rip it off, put your name on it. I'm throwing them away at the end of the day. Okay, so separate sheet of paper, geometric sequences. When is the test? Tuesday. That's Tuesday.